structure deep into the bedrock, meaning 101 is more than just resting on the earth. It's fused to it. This unique foundation, combined with 101's mega frame and damper, give the building an extraordinary earthquake safety rating that exceeds even that of Taiwan's nuclear power plants.
Inside the 101, during earthquake, you wash out the falling articles. Okay, rather than worry about the falling in the building.
Taipei 101 will not just be one of the strongest and most stable buildings in Taiwan, but one of the strongest and most stable buildings in the world. Building on the main megastructure begins in September 1999.
If I look back, I feel it was more difficult than I expected. But I didn't feel that way when I was working, solving the problems every day.
This isn't a construction workforce, it's a construction army. China steel plant, some of the most high-tech steel manufacturing techniques in the world are being used to build the various elements of 101's groundbreaking megastructure.
The basic idea of this building is so-called double tube structures, which means we using the steel frame to create the outside tube, and then we using the steel frame and the concrete columns to create inner tubes.
The steel used in Taipei 101 needs to be soft enough to weld, hard enough to carry the building's awesome bulk, and pliable or bendy enough not to weaken or break if it's rattled by an earthquake. Each of these requirements demands a different type of steel, a complex chemical cocktail of carbon, alloy, and refined iron. More carbon makes it stronger, but too much and it becomes stiff, brittle, and hard to weld. Xi'an plant develops 5 different kinds of steel for 101, each with a specific flex-to-strength ratio designed to suit its purpose and position in the building. The challenge for manufacturers is to make perfect steel into perfect components for 101 each time, every time, day after day. The integrity of 101's megastructure requires the super columns to act as single units. But joining 30 90-ton box sections into one seamless unit has never been done before. Yet again, 101 will tread new ground. Ordinary welding techniques simply won't cope with the enormity and detail of the task. Every millimeter of every joint requires absolute perfection. Teams of 6 welders work simultaneously. The entire girth of each joint has to be heated for the welds to bind. The scale of the task is mind-blowing. Each joint takes at least 14 hours to complete. That's nearly 2 years welding in the super columns alone. The high-strength steel and advanced welding techniques used in 101 super columns give the building a strong and flexible backbone built to withstand the shock waves of a severe earthquake. But dealing with the building's incredible weight demands an entirely different type of strength, one that steel alone cannot provide.
A building usually has 2 types of force, the tension force and the compression. And we all know steel works better for tension, and the concrete works better for compression.
The awesome weight or compression loading on the world's tallest structure would crush the super columns if they were hollow. but filling them with concrete to the 62nd floor combines the tensile strength of steel and the awesome compression strength of concrete. Making the system even more robust, engineers develop a concrete mix that is 60% stronger than normal. Concrete able to withstand an awesome 10,000 pounds per square inch of compression. The combined benefit of steel and concrete gives 101 the strongest, lightest, and most flexible backbone of any skyscraper on the planet. A backbone that is about to be put to the ultimate test. March 31st, 2002. A magnitude 6.8 earthquake rocks northern Taiwan. The entire island is brought to its knees. And in Taipei, only 135 kilometers from the quake epicenter, over 100 houses are destroyed, and at least 5 buildings collapse. The quake wreaks havoc on the construction site of 101. 2 purpose-built cranes topple 240 meters to the ground. 5 workers are killed and dozens more injured. A taxi driver fleeing his vehicle is crushed. Taipei is a disaster zone. All work on the building stops as aftershocks continue to strike. Insurance disputes rage, and engineers and surveyors check the massive building for hidden structural damage.
It was a big challenge for me at the time. The 9/11 attack that happened in the USA just before. And so our people and our investors began to question whether we needed such a tall building in Taipei.
The work ban continues, not just for days or weeks, but for 3 months. An earthquake, the very force 101 has been designed and built to survive, now threatens to destroy the building's future. Not physically, but financially. Morale plummets, and a dark cloud hangs over the project. Finally, in July 2002, the building surveyors give 101 a clean bill of health. The internal framework is intact, and once more, work can resume. But the victory is bittersweet. No scientific test could have proven so effectively that 101's megaframe can resist a severe earthquake. But no scientific test would have come at so great a cost. The notorious March 2002 earthquake has put 101's megaframe under the most extreme test imaginable. But as work resumes, and the skyline of Taipei is increasingly dominated by 101, a geologist from a prestigious local university discovers a worrying combination of data. Although only one severe earthquake has struck Taipei since work on 101 began, there has also been an unusually high number of smaller ones. Taipei 101 might not just be the victim of recent quakes, it might be the cause.
When the second failed earthquake occurred again, almost in the same location, then I take it very serious to do some research work.
The fact that Taipei is a seismic hotspot and that 101 is built only 200 meters from a dormant fault line is common knowledge. But the powers of the Earth are often hidden, and despite the combined effort of geological scientists the world over, accurately predicting when and where an earthquake will strike is beyond us. Dr. Lin believes the enormous weight of 101 may have reawakened Taipei's dormant fault lines, increasing the threat of earthquakes, not just to the building itself, but to the entire city. Although Dr. Lin cautiously states that this theory is not yet scientifically proven, the circumstantial evidence seems compelling. Bigger earthquakes, and more often, since the construction of Taipei 101 began. But foundation engineer Dunstan Chen explains why he believes this hypothesis is fatally flawed.
That's actually at the beginning. For every high-rise building I built in Taiwan, we consider the weight you put the weight of the structure, okay, should be more or less equivalent to the soil you excavated.
The net change in pressure on the Earth as a result of 101 is nil. 700,000 tons of construction has gone up, but 700,000 tons of earth was dug out to build it. The unpredictability of seismic activity means that either way, we may never know for sure. And regardless of what causes the frequent earthquakes in Taipei, this man-made marvel is being built to withstand them. Although concrete is one of the oldest and most widely used construction materials, it's incredibly heavy and, like a liquid time bomb, has to be pumped into position before it sets. These two factors pose a major challenge for construction workers on 101. The concrete they use here doesn't just have to get from the plant to the building, it has to get up the building as well.
Once you leave the benching plant, within 2 or 3 hours, you have to arrive on site and start pulling.
To do this, engineers develop concrete with specific levels of viscosity or runniness and specific drying times. This buys them valuable time and helps the powerful concrete pumps to work more efficiently. The result is yet another world record for 101. Concrete is pumped from ground level to 450 meters. That's higher than any other concrete pour in history. Construction reaches the 92nd floor in July 2003. Although nearing completion, the technological crown jewel of 101 is yet to be put in place. The tuned mass damper, the crucial windproofing mechanism designed to counteract the horizontal sway of 101's massive bulk. Although mass dampers have been used in skyscrapers before, they've never been this shape, they've never been this big, and at 380 meters, they've never been this high up. To be effective, the damper needs to be 1/10 of 1% of Taipei 101's total mass, a staggering 660 tons. Not even the awesome Taipei 101 cranes can lift something this huge and heavy. The ball arrives in prefabricated sections, which are then welded together on site. It's then hung from 16 10-centimeter thick cables and tuned to make it swing in exactly the opposite direction to the building.
When the building moved by the wind, it would go against it and balance it out real quickly, very much like the shock absorber on the car. And I think this idea has not been used in any other building that I know. So I think we're the first one to try that.
In principle, it works like a simple counterbalance, but in reality, things are a little more complicated and a lot more clever. To stop the damper from rocking either excessively or out of sync with the building, the ball is attached to a series of hydraulic dashpots, like mega shock absorbers, that stifle the ball's movement. If the damper experiences a particularly sudden jolt, such as an earthquake, the hydraulic resistance of the dashpots is strong enough to create a lockdown effect, meaning that the big golden ball in the sky will stay exactly where it is. If the mass damper is the technological crown jewel of 101, then the 60-meter pinnacle at the very peak of the building is the aesthetic equivalent. By late 2004, all major structural work has been finished on the main body of 101. Although this marks the successful completion of one of the most remarkable construction endeavors ever attempted, 101 is still 4 meters short of being the tallest building in the world. Successfully raising the pinnacle will assure them the title, but at 400 tons, it will also be a logistical nightmare. Nothing this heavy has ever been lifted in this way at this height. It's not just difficult, it's dangerous. A system of hydraulic jacks and geared cables lifts the massive structure from its base. Progress is painfully slow, but victory is the only option. Finally, after 14 days, the pinnacle is secured. Against all odds and against nature, the tallest building in the world is complete. Yet although this marks the end of one phase of the building's life, it is the beginning of another. Today, some of the world's biggest corporations boast offices here, and in peak periods, up to 40,000 people come in and out of the building every day. It's like a city unto itself, only vertical.
For a lot of people, until you see it, you don't believe it, nor do you understand it.
Many of the everyday functions we take for granted are complicated exponentially by the addition of height, making the operations of this mega skyscraper a mega challenge. Every minute detail of the building is monitored and accessed in here, the central control room. From the speed of every fan on every air conditioning duct to each of the 96 elevators, Operations Manager Jeff Shu and his staff can see and control it all. The security section monitors the focus, angle, and zoom of each of 101's 520 surveillance cameras. The locks on even the most obscure doors are hardwired into the vast central brain of the security system. Staff continuously monitor the use and supply of electricity, the flow of water, the fire hoses in the mall, even the level of seismic activity. Every visitor is photographed and checked twice without them even realizing. Sucks in the equivalent energy of 6,000 regular homes. It's dependent on 2 designated city substations and has backup generators in case of failure. There's enough electrical cabling in 101 to stretch from Taipei to New York and back again. In case of fire, the equivalent of 2 Olympic-sized swimming pools of water is stored within the building to fuel a vast array of sprinkler systems. Stairways and corridors leading to the mechanical floor safety zones are pressurized to reduce smoke levels and are equipped with personal emergency kits, closed-circuit TV, and, perhaps most importantly, access to the outside world. On a building of this height, matters as simple as flushing a toilet pose serious challenges. 1 liter of water falling from the top floor of 101 will have the same impact as a house brick traveling at 65 kilometers per hour. Sewerage tanks on every mechanical floor contain, process, and transfer gray water safely to the ground. The elevators are the fastest in the world. Traveling at 60 kilometers per hour, they go from level 5 to level 89 in only 37 seconds. Each carriage is pressurized to avoid ear damage, streamlined to minimize noise, and electronically balanced to ensure a ride so smooth that even a coin won't topple on the incredible journey. To clean each of 101's 17,000 windows, custom-built gondolas dangle workers off the edge of the building. They can only work when the wind is under 10 meters per second. And even then, the cables have to be hooked into the walls to stop the gondola blowing off track. The awkward angle of 101 means that an elaborate counterweight system has to be used so that workers can get close enough to the walls to work. To clean the entire building takes 4 teams of 2 workers 3 months. The job is so big that as soon as it's finished, it's time to start again. Inside and out, Taipei 101 pushes the boundaries. A unique-looking building that has changed the face of construction, design, and engineering forever. The tallest building in the world, in one of the most hazard-prone places on the planet. Defying the powers of earth and wind, to go where no building has gone before.
It's really a very, very important building. It is a landmark, it is a benchmark.
Long after its mantle of world's tallest has gone, its achievement will remain. A symbol for the future of a proud island. A skyscraper that took on nature and won.
接下来，它的设计功能是寻找宇宙的起源。凭着50亿美金的造价，它成为了历史上最昂贵的物理实验。
好，我们
建筑巨
休息10分钟
接着播出。
大家再讨论一下。
你这样疯了！干他跑超快，操你妈的！
好，来，起绳啊，起绳啊，起绳啊，再忍耐23分钟，你们就可以下课了。就这样，睡到感冒，对不对？睡到感冒哦。好，我们来分享一下，我们刚才看台北101大楼，台北101大楼，它在做这个工程的时候，它遇到了什么样比较严重的一个问题待解决的？地震跟台风就这2个，对，而且它要处于什么地方？地震带，对，所以要克服这样的问题。那么，它用什么方法去处理有关于台风所造成会晃动的问题？那还不是最主要的哦。那个什么球，不是，它之前还有一个叫锯齿角，锯齿角可以减少在40%的风力造成的影响。在剩下的部分呢，就用阻尼器，去协助它，所以这在全世界也是创举，因为没有那么大颗的，而且很厉害的是，我们用了8支那个最主要的主干去作为110的那个主要的，对，它还有个特性就是它不能太硬，它还有一定的软度，才能让这101在比如地震的时候呢，不会摇晃得太过分。那我们知道，如果说像一个如果高高的这种摇晃太过分的话，会超过，对不对？所以它阻尼器还多了一个功能，它下面有几个油压的棒子，不要让里面的阻尼器晃太过。所以这101大楼就是要处理有关于地震跟台风的问题。然后它在有一次